Okay, so we're doing chapter 2. Alright, so I'm only gonna do one of these because they are pretty much the same exact thing, and I don't like wasting my time. So, what we're gonna do is I'm gonna first show you a two variable, then I'm going to do two three variables, and then we're going to do graphing and then do word problems. Word problems I'm not going to solve because of the fact that I'm going to set them up and you can solve them if you want. Now, one thing you can tell you made a mistake is if you get a decimal in my class. In actual system of equations, you could actually get a decimal, but in this case, we're not getting decimals because I just would rather you find your mistake that way and figuring out, oh, I got a decimal. Alright, so we got this. Now, what is it? So, what you have to do is you have to pick what letter you want to eliminate. So I'm going to look at this and I'm going to think in my head, alright, which letter is easier to eliminate? Can I multiply 6 to get to 9 or 9 to get to 6? No, I can't. Can I multiply 6 to get to 5 or 5 to get to 6? Once again, the answer is no. So what I like to do next is see, is there something, is one of the letters already have a positive and negative? If so, let me choose that because that way I don't have to multiply it by a negative number and accidentally screw something up. Well, the x's are both positive, so that doesn't work. How about the y's? Well, that's positive, that's negative. Great, I'm going to use these since it's going to be easier on me mentally. So, what I'm going to do next is I'm going to think, well, what's the first number both 5 and 6 multiplied to? That's the harder way. The easier way is just to do this. Well, I can multiply this top equation by 5 and multiply this bottom equation by 6. Why? Because all you're doing is multiplying by the opposite number. That's the easy way. That way you don't really have to figure out what the least common number multiple is. It's going to give you bigger numbers, yeah, but it's consistent and you don't screw it up ever. Alright, so now that I'm multiplying both equations, it doesn't always work like this, but in this case it has to. I have to distribute this 5 to all three things. So first I'm going to distribute this 5 to the 9. That gives me 45x. I'm going to distribute this 5 to the 6. That's going to give me 30y. And then I'm going to distribute this 5 to this 36. And I think that gives me 180. Yep, that's 180. Alright, that gives me 180. Do the same thing down here. Gives me 36x. Because I multiply 6 by 6 now, and then 6 times negative 5 is negative 30y. And then finally, 6 times negative 3 gives me negative 18. Alright, so let's bring everything down. We're going to combine these together. The reason why we can do this is because the point that works for both of these is going to be the same point that works for multiple of these. Now, if you don't really understand what I mean, just know that it's not magic. It's that if I multiply this by 5, it's still the same equation. It's just got bigger numbers. Okay? So I'm not actually doing much. And now, since I'm adding these together, what that means is I'm doing this because of the fact that if I'm trying to eliminate a variable, and since these are the same thing and the variables mean the same thing, combining them together won't actually do anything to our math. So that crosses out. This becomes 81x. This gives me 162. We get to here. Now, I have a variable by itself, which is what I was trying to get to. The reason why is you cannot solve for two variables. There's too many there's too many different possibilities. But I could definitely solve for one variable. So I'm going to divide by 81. X gives me 2. So I have X is 2. Now I can figure out what my Y is. Well, I'm going to go back to my original two equations. I'm going to plug X or 2 and for the x. The reason I do this is so I can figure out my answer to y. So I'm going to take my 6. I'm going to take the second one. It doesn't matter which, they'll come out to the same answer. I'm just going to do the second one just because I want to. Notice how I did not replace the coefficient, but I replaced the x itself with 2. This gives me 12 minus 5y equals negative 3. I'm at this point. Now this becomes a two-step equation. I have to get rid of the thing that's not next to the y because I'm trying to get y by itself. So I'm going to get rid of this 12. That's going to give me negative 5y equals negative 15. My last step is divide by negative 5. Y gives me 3. So my point is 2, 3. This is the point where these two lines cross on a two-dimensional surface. So if I drew two lines, if I graph those two lines on the map, they're going to cross at 2, 3. Now let's go on to the next thing. Alright, some of these, like, I'm only going to be able to do 2 of them because for some reason the printer sucks. And I have no idea what these are. So we're going to do this first one. Because, hey, printer sucks. And the second one, you can't even read anything. So, what I have to do is I'm going to eliminate either the x's, the y's, or the z's. We're doing the same idea as last time, where we have to systematically eliminate one variable, then eliminate the next variable until we are left with one variable so that we can solve for that one variable. So, we have to go from 3 equations to 2 equations, and then from 3, and then those 2 equations need to go from 3 variables to 2 variables. And the reason why is we're going to try to systematically eliminate these variables. Now, looking at this, I'm going to tell you which one's the easiest to do. X's are the hardest. Why? Because 5 cannot multiply to 11, 6 can't multiply 11, and 5 cannot multiply to 6. Since none of those can multiply to each other, it's the longest route to go that way. Let's look at the y's. I have a 6, a 3, and a 3. I already have a positive negative 3, so that's already easy to eliminate. And I know 3 times 2 gives me 6, so that's going to be easy to eliminate. So what I'm going to do is I'm going to choose the y's here. So, what I'm going to do first is I'm going to choose 2 equations. I'm going to choose the second one and this third one. What I'm going to have to do here is try to eliminate these y's. In order to do that, I have to make sure that I have a positive and negative of the same number. So I have 11x plus 3y plus 10z equals 63. Now I always tell you guys to put a little line through this to make sure you know it's a z. Otherwise you guys are going to put that as a 2 and then you're like 102 plus 252 equals so on and so forth, and then you're going to be confused. So, make sure you know that's a z. The next equation is 5x minus 3y plus 25z equals negative 24. So let's look at the y's. Do I have a positive and negative of the same number? The answer is yes. So I can do the next step after that, which is to add downwards. This becomes 16x. That crosses out. This becomes 35z. And then this becomes, what, 39? So, that gives me my first 2-variable equation. I gotta do this process again, and when I do this process, I need to eliminate the same variable. So to do this again, I have to choose the third equation I haven't used yet. I at least have to include that guy because everyone needs a turn. Otherwise, he's going to feel lonely, and then the entire problem's going to fail. The next thing is figure out which equation's going to deal best with this equation. I have a negative 3. I have a positive 3. This is a positive 6. I need a negative and a positive. So I already have my negative, I have my positive, so I might as well use this third equation. It wouldn't be wrong to use the second one. It just becomes a little more difficult. Now, I need to make these the same number. And I know if I take 3 and multiply it by 2, I will get to 6. And since it's a negative 3, that'll give me the negative 6 I need. So I'm only going to multiply one of these equations this time. And it's going to be this one right here. Sometimes you have to multiply both, but this way I don't have to. Now I'm going to distribute this. This is going to give me 10x minus 6y plus 50z equals negative 48. I'm going to rewrite this one above it so that we don't get confused where things came from. Okay. So let's add downwards. This gives me 16x. This crosses out. This gives me 45z. And then this gives me, what? 9. So now I have two equations with the same two variables that I can deal with. So what I'm going to do is I'm going to come down here and I'm going to rewrite those two equations. 16x plus 35y, or z, equals 39. And then 16x plus 45z equals 9. We're going to do this like we did on the front page, or the first thing that we went over. And that is to try to figure out which one do we want to eliminate, and then make a positive and negative version of the same number so that we can solve for that variable, or solve for the other variable, and eliminate it. Notice the name, elimination method. We're eliminating variables. That's where it gets its name from. Alright. These are already 16s. I think this is a no-brainer. We need to do the x's. The only problem is one positive, one is negative. So I'm going to try to make this negative by multiplying this entire thing by negative 1. What that's going to give me is negative 16x minus 45z equals negative 9. That part is 16x plus, I don't know why I didn't put the 5 there, plus 35z equals 39. When you add these downwards, this gives you negative 10z equals 30. Then you divide by negative 10, divide by negative 10, z gives you negative 3. So I have my z. Now I have to go from the one variable back to the two variables. That means one of these two equations. I'm going to plug z in for one of these two. I'm going to pick this first one. I don't know why. I'm just doing it. It doesn't actually matter. So I'm going to take that 16. So I'm going to start up here. I'm going to take that 16x plus 35, and I'm going to take that 35 and multiply it by negative 3 equals 39. Okay? This is 16x minus 105 equals 39. I'm going to add 105. That's 16x equals 144. And then I'm going to solve for x. X gives me 9. So now I have two of my variables, my first and my second variable. Now I need to get my third variable. Since I have two of these variables, I can actually go back to our original equations and plug in for the two variables to leave one variable left over. So what I'm going to do is I'm going to take this first one, I'm going to plug everything in. So we know x is 9 plus 6y minus 5 times negative 3 equals 57. Well, I know 6 times 9 is 54 plus 6y plus 15 equals 57. And now I need to combine like terms. These two are like terms. That gives me 69 plus 6y equals 57. Need to get rid of the 69 minus 69. 6y equals negative 12. Last but not least, you divide by 6. Divide by 6, y gives you negative 2. Now, technically you're supposed to take all three of these numbers and plug them into each of these to make sure that it's correct. But if you get three solid numbers, I'm going to tell you about 80% you're going to get it right in my class. Okay? The reason why it's 80% is, sometimes, actually I'd say about 90%. Sometimes I don't know how you guys get three numbers that have no decimals and none of them are right. But I don't know. Alright, we're going to do the same thing in this one. Alright, so let's look at the process. 3 can multiply to 6, but it can't multiply to 7. Alright, so x's are okay, but they're not the greatest. 9 can multiply to 8. 9 can't multiply to 8. 8 can't multiply to 9. 5 can't multiply to 8. Y's kind of suck, so I'm going to skip those. 3 can multiply to 6, and 2 can multiply to 6. So actually, I'm going to try the z's because, yeah. So, I'm going to do these first two because I know negative 3 times 2 is going to give me negative 6, which is exactly where I want to be. So that's why I'm going to choose these. So that gives me 7x minus 9y plus 6z equals negative 93, and 3x plus 8y minus 3z gives me 55. Alright, now what I have to do next is I need to multiply this equation by 2. I'm going to rewrite the 7x minus 9y plus 6z equals negative 93, just so I have it down. Alright, so the first part is 6x plus 16y minus 6z equals 110. Add downwards because these are the opposite numbers. Cancel out. This gives you 7y, this gives you 13x, and then this gives you, was it 17? Now I'm going to pick this last one and this one up here. So it gives me 7x minus 9y plus 6z equals negative 93. 6x minus 5y plus 2z equals negative 58. Remember, I need to make this an opposite of this, so I need to make this into a negative 6. So I have to multiply by negative 3. So I'm going to rewrite 7x minus 9y plus 6z as that is life. And then we're going to distribute this. I'm going to give it negative 18x. This is going to be negative times negative, which is the positive 15y. Negative times positive is negative 6z, just what we wanted. And then finally, this would be 174. Dot downwards, that gives me negative 11x. Gives me 6y. And this crosses out, and this gives me what? For some reason, I can't do math in my head. So 174 minus 93 gives me 81. Alright, I have my two equations. Got this one, got this one. So, I'm going to put them over here. I know I am not saving room, but as is life, I don't know why I'm saying that. Alright, 13x plus 7y equals 17. Negative 11x plus 6y equals 81. Okay. Once again, we got a situation where I can't multiply anything to get to anything else. So what I'm going to do is I'm going to go off which one's already positive and negative, and this is already giving me a positive negative. So as I told you before, just take the easy route, multiply by opposites. And when you do so, 11 times 13 gives me 143. X plus 77y equals 187. And then this gives me negative 143x Plus, what is 13 times 6? 78. Y equals 81 times 13. 10, 53. Alright, like before, I'm going to combine downwards. This is going to give me 155. Y equals 2240? Yeah, we're going to go with that. And then I divide by 155. Y gives me 8. Alright, I know what Y is. I take this, plug it back into one of the two variable equations, not the 3-1, because you guys are going to try to do that, and then you're going to be like, I don't understand. But you have to go to the two variable ones, okay? So you go back to one of your two variables. I'm just going to do the first one. Does not actually have a rhyme or reason. Just want to do the first one. Equals 17. That means that 13x plus 56 gives me 17. I subtract 56. Subtract 56, and that's going to give me negative 39, and that's 13x. And then we're going to divide by 13. We're going to divide by 13. X gives me negative 3. Okay, so I have my x, I have my y. Let's go plug into this. I'm going to choose the first equation. If you guys have everything in front of you, you should know what the first equation is. So it's going to be 7 times x, which is negative 3 now, minus 9 times 8, which was what replaced y, equals 6z, equals negative 93. This gives me negative 21. This gives me negative 72 plus 6z equals negative 93. This is actually negative 93 plus 6z equals negative 93. Add 93. 6z equals 0. So we automatically know z has to be 0. Alright, so those are the three variable equations. Now, let's do the word problems. Okay, I guess I only made two. I'm only going to do one of these. Why? Because I only want to do one. So, what we have to do is you always need to make your variables first. I'm going to read this out loud, then we're going to go over to figure out what are my variables. A choir group is selling tickets to the show and are charging members one price and non-members another price. The first night they sell 18 tickets, member tickets, and 35 non-member tickets for a total of $229. The second night they sold 34 member tickets and 7 non-member tickets for a total of $137. How much was the member and non-member tickets? So, I keep hearing member and non-member. So I can tell you right now, my X is probably going to be my member price. Y is going to be my non-member price. Now, when I do this, I want to go through this and make an equation that has both this X and the Y. And to do that, I need to look at these numbers. When I see 18, what do I see it next to? I see it next to member tickets. So I'm going to put 18x for the first equation, plus 35y equals a total of 229. That was the first night. The second night was 34x plus 7y equals 137. It's as simple as just reading through it and figuring out what's being talked about the most, and then making those our variables. Because most likely, that's what it actually tells you in the question, like what are these ticket prices. But it also says a lot in the problem. So being able to pick that out actually helps a lot. All right. Last but not least, are these things. Now, I'm just going to explain these more so than graphing them because I want you guys to be able to actually graph these and test these out yourself, make sure you understand what you're doing, so on and so forth. Now, we have a couple of different things that we need to go over. First being are these symbols. When you make your line, you're going to make a dotted line if you have this symbol. For example, this symbol, when I connect my y-intercept to the second point I make with my slope, I had to use a dotted line because of this. This gives you a solid line. That little line underneath the inequality sign means solid line. Okay? So that's how you can tell the difference between solid and dotted. Now, if you see a less than sign, that means that you're shading below whatever line you create. So if you create a line that looks like that, less than, you shade below it. This one is a greater than, so if you make a line like that, you would shade above the line, which would look like that. Now, where the two lines, where the two shaded areas meet, for example, if I shaded above the line here, and I shaded below the line here, where the two shaded areas meet is called your solution area. And it's the area you should darken because any point from this area, if plugged into these two equations, will make both equations true. Now, when I look at something like this, where it doesn't have a slope or a y-intercept, I can tell you right now, you're going to be making either a horizontal or vertical line. Now, since it's y, we know we have to go through the y-axis, and since we have to go through the y-axis, it means we have to make a line that goes horizontally. Okay? This tells you once again the shade above or below, but in this case you'd make a line at 3 horizontally. Last but not least are problems that look like this. When you have problems that look like this, you have only two simple steps. You should add or subtract the x, then divide by what's in front of the y. Simple as that. 3, it's a positive 3. I have to subtract the x because it's that. This has an x, this does not. If you combine these together, you're going to not get this problem right. These are not like terms, meaning that we just write them separately. Nothing has to be done to them. You don't need to consolidate everything in math. Sometimes it just looks like that. Okay? And then we're going to divide by the y for step 2. Well, y is 4, so I divide here, here, and here. This crosses out, leaving me y is less than or equal to. This is negative 3/4 x. And then finally, this is 3. And that is your answer. That's how you would graph it. Now, the only last thing that you need to know is that if this number from this y was negative, I would flip the inequality sign so it would face the other direction. But because it was positive, I don't actually have to do that. From there, you graph, you do the same thing as above, so on and so forth. Alright, thanks for listening.